Flash point is a key indicator of product flammability and therefore safe handling practices. As refinery feedstocks become increasingly diverse, fuel producers need ever smarter process control to ensure that finished fuels meet the specifications of regulatory agencies. Hi, I'm Corentin Thierry, Sales Manager here at BARTEC US for our PAT Group Process Analyzer Technology. In this video, we will be reviewing one of BARTEC's solutions for flashpoint measurement, the BARTEC Orb P500 out of our factory in Chicago. Before we dive into P500, let's first take a look at what flashpoint is. Flashpoint is a measurement of temperature. It is the measurement of the temperature at which the vapors or fumes of a sample will ignite under an ignition source, such as a flame. In the US, flashpoint is used to define flammability and combustibility of samples. It is determined that products with flashpoint below 100 degrees Fahrenheit or 37.8 degrees Celsius are flammable and therefore need higher precautions when handling them. How do we measure flashpoint in the laboratory? So the apparatus you can see here is used to measure flashpoint. A sample is heated and agitated, and at a regular interval, it will be exposed to the ignition source. Commonly, those laboratory apparatus are composed of the ignition source, the agitator, and then a sample cup. Now, why is flashpoint an important measurement? Well, the first reason is regulatory compliance. Diesel fuel must have a certain flashpoint to be sold on the market. The second reason is a quality requirement. As with diesel, jet fuel also has a flashpoint requirement because we want to ensure that the jet fuel will be properly combusted in turbine engines when a plane is flying. And finally, the third aspect is for safety. As mentioned earlier, flashpoint is used to monitor the flammability or combustibility of a product. And therefore, by knowing the flashpoint, we know how a product should be handled. To my right is a 3D rendering of the P500. At the bottom right, we have the measurement enclosure, where the actual flashpoint measurement takes place. At the top right, we have the electronics enclosure, where the signals are being processed by the processor. And at the top left, we have a signal and power junction box to be able to connect the analyzer to both power and DCS. The P500 weighs about 500 pounds, including the stand. Its overall dimension is about 3 feet wide by 6 feet tall. In the following animation, we will go over how the measurement is actually done in the bottom right enclosure, the measurement enclosure. The P500 is a cyclical analyzer. Both air and sample continuously flow through the measurement cell or the flash cup. The sample passes by a heater that increases the temperature of the sample before reaching the flash cup. At the beginning of the measurement, the electrodes are cleaned by igniting the spark plug and the transducer is zeroed. Then on a regular interval, the spark plugs as ignition source are turned on until an explosion has been reached. As the explosion occurs, a high pressure spike is recorded by the pressure transducer, which is then correlated to sample temperature and recorded as the flashpoint. The cycle starts over. Now that you know how the P500 measures flashpoint, let's go over some of the features of the P500 flashpoint analyzer. First of all, it's manufactured out of our BARTEC Orb facility in Chicago in the US. It is designed to meet NEC and CEC Division 1 hazardous area and ATEX IECEX Zone 1 areas. It uses an EXD protection method, commonly known as X-proof or flame-proof. It is fully compliant to both the ASTM D56 and D93 methods. The flashpoint measuring range goes from 25 to 125 degrees Celsius or 75 to 250 degrees Fahrenheit with a repeatability of 1 degree Celsius or 2 degrees Fahrenheit. And finally, the full measurement happens in 5 minutes or below, depending on the application. Now that we've gone over some of the features, let's talk about the benefits that make the P500 so great for flashpoint analysis. First of all, the P500 is not influenced by sulfur and can therefore handle any sulfur concentration in the fuel stream. The P500 has been built with easy maintenance in mind, and therefore the flash cup assembly is easy to disassemble, allowing quick and efficient access for the maintenance and cleaning of the cup. The P500 also has the ability to input a variable heating rate to control the heating of the sample and thus meeting the requirements of the sample for the specific analysis. The P500 is also designed to handle high viscosity up to 180 centipoise at 40 degrees centigrade or 105 degrees Celsius, making it suitable for fuels like RMK 180, marine fuel. And finally, as with all our other analyzers, the P500 can be fully integrated at both our BARTEC Orb and BARTEC Benke facilities, thus allowing us to provide a full solution to the needs of the customer. Now that you know how the P500 does the analysis, the features of the P500, and what makes the P500 so great at flashpoint measurement, let's go over where the P500 is installed, on what type of applications. The first type and most common type is in fuels. And this can be in blending terminals, where it is used to monitor the flashpoint of diesel, jet fuel, kerosene, and mixes of those various fuels, as well as in processing units, when it is used to monitor intermediary step in the manufacturing of diesel, jet fuel, kerosene, and such related fuels. Another field of application is in the chemicals industry, where we will see flashpoint measurement for quality control and safety applications related to, as I said earlier, flammability and combustibility of sample. Now that you're familiarized with the P500, its features, the benefits for flashpoint analysis, and where it is installed, reach out to us and you will see the difference that knowledge, expertise, and decades of experience in physical property analyzers will make for your project, integration needs, and meeting your demands. Thank you, and we will be talking to you soon.